Hello everyone, my name is Yetunde Sokefun. I'm a third year PhD student at the University of South Florida. I currently work as a research assistant in the Heterogeneous Catalysis and Materials Chemistry group in the Department of Chemical and Biomedical Engineering at the University of South Florida. I currently do research with Dr. John Kuhn and Dr. Babu Joseph. Our research is on the intensified production of liquid fuels from landfill gas. Landfills emit biogas. Biogas are gotten from the anaerobic digestion of solid waste. I became particularly interested in solid waste growing up. I became aware of the large volumes of solid waste that are produced in my country, and however, there are only a small percentage of those that are treated and properly disposed of. So I started looking into solid waste disposal, and I became aware of solid waste management and the different waste to energy technologies. So when I started thinking of graduate school, I decided to go into research in that area, and I looked up various professors that were working in the waste to energy technologies, and it was interesting to find professors like Dr. John Kuhn and Dr. Babu Joseph here at the University of South Florida. An added benefit of our research is it helps to reduce the environmental impact of gases such as methane and carbon dioxide. Our research enables us to convert these harmful gases to synthetic gas, and this synthetic gas can be converted to valuable chemicals or liquid fuels. So our project is reducing the environmental impact of harmful gases while also providing liquid fuels. The most exciting thing I discovered about my research is that effective solid waste management goes beyond landfilling. There are actually other interesting waste to energy technologies such as gasification, pyrolysis, anaerobic digestion that a municipality or region could employ in converting their waste to energy. So you're not it's interesting to learn that you're not exactly limited to just one waste to energy technology. You could decide on whichever one you want to use based on constraints such as your availability of land, the taxes involved, the government policies. The most exciting thing I learned about my research is that effective solid waste management goes beyond the common landfilling. There are other waste to energy technologies such as gasification, pyrolysis, and anaerobic digestions that could be used, and there are benefits that could be gotten from using this waste to energy. The partnership between Hinkley Center, educational institutions, principal investigators, and students will enable the development of research that will provide results that will be applicable to various public and private sectors. This area of study is particularly important because it helps to provide solutions to two problems. One is the effective management of the large volume of solid waste that's presently being generated, and it also helps to provide an alternative source of energy production. In addition, it also helps to deal with the environmental problems that arise from the emission of gases such as carbon dioxide and methane. Our research enables us to convert these harmful gases to liquid fuels. I became motivated to work in this area of research because I grew up in a country that produces a large volume of solid waste. However, only a small percentage of the solid waste are effectively managed. So when I was considering graduate schools, I started looking into researches on solid waste management, and it was interesting to find research area that involved the production of energy from solid waste. I would like to thank the Hinkley Center for providing funding for this research. I would like to thank my undergraduate professor, Dr. Tolu Ajayi, for giving me my first introduction into waste production and management. I would like to thank my current professors, Dr. John Kuhn and Dr. Babu Joseph, for giving me the opportunity to work on this research, and I also appreciate their guidance throughout the work.